Alright, so I'm going to use a problem from the next module in the course where we actually start solving some basic linear programming problems, like the one we have here. To solve these, we have to graph systems of inequalities. So I want to show how to use Geogebra to do this for this system of inequalities that we have in our problem here, highlighted here. All right, so we've opened up Geogebra 5, and all we have to do is type in these inequalities. So on the input line at the bottom, I'm just going to type x plus 2y, and then for less than or equal, I just put a less than and then an equals, and we have 150. Oh, actually, I want to do the equations. You can graph the inequalities, but it doesn't lead to a good image for saving. So I grab the first line. You notice I can't see it because I have to move my screen around. I can zoom in or out until we see that line. And then we enter the next one, which is 3x plus 4y equals 200. And then we want to do 5x plus y equals 175. And then the axes, x equals 0, y equals 0. Now I can kind of zoom in around the action here, and you can use this to just drag your screen around. And again, we can put the labels. You can click on a line. Notice the labels were put on here, but we can click on one of these lines, open the object properties, and you can change colors and what the label is going to be. So for the label, we'll put the value. That would give me the equation of the line. And color, if I want to change the color, I could make it dark blue. Another thing we can do is go to options and make the font size bigger so it's easier to read. And then you can you're limited to where you can put this label, but you can kind of move it around if necessary. And then let's go ahead and pick another line. Do the same thing. So use red for this one. Change the label to value so we get the equation of the line showing. And then do this third line here. Same thing. Let's use maybe get the label, change the color, green. We can adjust the size and shape of this image later. Let's just do the last two, the axes. Purple. You don't have to put them all different colors, but you just want to be able to tell the difference between which lines, especially if the labels are going to be close to each other. You won't be able to tell which line is which, or at least the reader won't. And again, the value, just so the equation of the line is there. And it's actually showing the wrong line. I need to fix that to be 0. And the the vertical axis. Value again, and then the color. Orange. That's a little difficult to see, so let's try something else. A little darker. All right, you can play around with these options. And at this point, we can kind of open this up, make it a little bigger. Again, we can zoom in or out to get a better image and move it around. You have to use this cursor to grab and move objects. Shrink this down a little bit again. So again, looking at our system itself, if we look at the first constraint, if we were to solve that for y, it'll be y less than or equal to something. So we want to be below that line. So we want the points below this blue line. For the second constraint, again, it'll end up being y less than or equal to something when we solve for y. So we want to be below that line as well. So below the green line as well. And then the last equation, or inequality here, or not the last one, but the last kind of non-simple one, it will also be y less than or equal to something if we solve for y. So we need to be points that are below the blue line, the red line, and the green line simultaneously. But we also need only points whose x and y coordinates are non-negative. So if we kind of zoom in on that, move things around a bit, we can see that that region is going to be this four-sided polygon here. These are the points that satisfy all of the linear inequalities. They're below the blue, red, and green, and they're in the upper right quadrant. So in fact, the red line here, that inequality, is a redundant inequality. We don't actually need it. It's part of the problem, and this is natural to have happen. But for graphing this, we don't need anything. So we can use the polygon function. And all you do is you go to the vertices and you click, and you can go all the way around. So I see that I'm move my cursor and it tells me where I am. I'm at the intersection of these two lines. So I'm going to click, go down, find the intersection of two more lines, intersection of those lines, and then I just have to complete the cycle by going back to the first point A. So that's shaded it for me. Now notice all these labels are being put on. In the beginning, what you can do is go to labeling and say no new objects, and it won't put any labels on. You can put them on later. So we can go through and turn these off. Oh, hold on a second. I added a dot here. Didn't want to do that. So you can always go back. Undo something I did. Oh, let's redo. All right. So we get back to the cursor. Let's get rid of these line segment labels. Don't want those. Again, if we would have turned it off from the beginning, we wouldn't have to do this. This little B. A. Now the labels for these points, I'd like to make them all black, say, so I'm going to change this one to be black. It was blue for some reason. Just make that black. And we're going to change it to the value of the coordinate of the point. So the point 0, 0. Now these numbers on their axes are kind of annoying too in this problem, in this case, so we can go up here on this kind of gear looking thing and hit graphics. Go to the grid. You can turn grid on and off. It's off. We don't need it on. But our axes, we can take away the numbers. Take away the number. Oh, show the axis, but take away the numbers. Now we can move our 0, 0 point somewhere there. Our point C. Again, it's not black. Let's make sure it's black. Doesn't matter, but oh, I forgot to change the value. Let's go to basic label value. That'll put the coordinates of the point there. I can move that. Do the same for points D and A. Change it to value. Change it to value. Now I have my feasible region, and I can change the color of this if you want, just by clicking on the middle of it. I'm going to make it some other color, maybe a dark gray or something like that. So this is our feasible region, and Again, we don't need all that. When you export an image, it's going to basically use whatever's in the window here. So you shrink the window down and size your picture up the way you want it. For example, I want to kind of move it around, maybe make it bigger. Let's make it a little bigger, then move it back over into the center of the screen. And you can see that we just want to see that the labels are easy to read. You just got to kind of play around until you can move them to where you want them to be, so you can kind of see everything. It's okay if your label goes through the line. You can read what that says. These two labels are on top of each other, so kind of make them not on top of each other. The colors make it easy, so you don't have to worry about exactly where they are. But anyways, this produces an image which has our feasible set, and it has the coordinates of the vertices which we need to solve the problem. And then if you just want to export the file, you have lots of options. I use LaTeX, so I export these as an EPS, encapsulated PostScript file, but you can use other image files, whatever you can use to import into your assignment if you need to put the image into your assignment, depending on if you're using Word or something else. But you can export. I would export this and just name it and save it. And then I have the image that I can use.